Hello there, and welcome to the Science for Sleep. Tonight, we drift gently through the seasons, the quiet, ancient rhythms that govern our world, the slow dance of light and shadow that shapes all life upon the earth. From the shimmer of summer heat to the frozen stillness of winter, every season rewrites the story of existence in its own unique and tender way. Across oceans, deserts, and forests, an invisible rhythm hums beneath it all. It pulls the tides, guides the migrations, paints the skies in shifting colors older than memory itself. Even the stars seem to sway to this cosmic rhythm, and the air we breathe, along with our body's deepest cycles, are all influenced by it. The seasons are more than changes in weather. They are the heartbeat of time itself, the pulse of our planet turning endlessly around the sun. So take a deep breath, let your eyes grow heavy, and allow the rhythm of the seasons to cradle your thoughts as we begin this quiet journey through Earth's timeless balance. The existence of seasons begins with a simple tilt. Earth's axis leans about 23.5 degrees from the vertical. That small inclination is the hidden rhythm behind every pattern of warmth, cold, and light that shapes our days. Because Earth travels around the sun with that slight lean, sunlight spreads unevenly across the globe throughout the year. In June, the northern hemisphere tilts toward the sun, and sunlight strikes more directly, flooding the lands with heat and long days. 6 months later, the northern hemisphere tilts away, and the light weakens, sinking low in the sky as winter arrives. This quiet geometry, this celestial angle, divides the year into seasons and sculpts the world's climates. Without it, there would be no spring or autumn, no cycle of bloom and rest, no harvest, and no renewal. Every calendar, every culture, every ritual tied to planting or celebration is an echo of that cosmic lean. The tilt gives time its rhythm, life its pattern, and the earth its heartbeat. If that tilt vanished, the world would fall into an eerie stillness. Day length would never change, and the sun would rise and set at nearly the same spot every day. Regions near the equator would bake endlessly beneath relentless heat, while the poles would freeze in perpetual cold. There would be no seasons, no balance between light and shadow, only monotony. Winds would weaken, rainfall would lose its rhythm, and storms would fade, for it is the contrast between warm and cold air that fuels their power. Ecosystems would collapse beneath such sameness. Crops would fail because they rely on seasonal changes in light to know when to flower and fruit. Animal migrations would falter, breeding cycles would lose their signals, and the world's diversity would dim. The tilt of Earth's axis, then, is not a trivial detail of physics. It is the living pulse that keeps every ecosystem breathing, rising, and renewing with each circuit around the sun. Yet even small changes in that tilt could reshape the world entirely. If Earth leaned just a few degrees more, summers would grow searingly hot while winters plunged into deadly cold. Continents would be scorched and frozen in turn. The sun would climb higher across the sky in summer and sink lower in winter, stretching the extremes of light and darkness. At the poles, ice sheets would melt away during endless daylight, flooding coasts and reshaping oceans, only to return in deep, months-long darkness. Near the equator, fierce monsoons would shift unpredictably, rainforests might dry into savannas, and fertile farmlands could fade into desert. Civilization itself would struggle to survive a planet lurching between extremes. The tilt we have now, steady, moderate, and merciful, is a delicate balance between chaos and calm, allowing climates, forests, and oceans to synchronize their breathing in a rhythm gentle enough for life to flourish. It is a narrow band of balance in a vast and unpredictable universe. But this stability is not ours alone to credit. Our moon, quietly orbiting above, plays an essential role in keeping Earth steady. Without it, Earth's tilt would wobble dramatically over time, swinging between upright and steeply inclined positions. This slow drift would send ice sheets and deserts migrating across continents, erasing ecosystems and reshaping climates over thousands of years. Mars, which lacks a large moon, already experiences this kind of chaos. Its poles tilt toward and away from the sun over long cycles, drastically changing its climate. The moon's gravitational pull anchors Earth, limiting our axial wobble to just a few degrees. This subtle tug is what allows long-term climate stability, giving us the dependable cycle of spring and winter, summer and autumn, year after year. Every gentle shift in light, every season we know, exists because of this quiet cosmic partnership between Earth and its moon. When Earth's tilt decreases, the contrast between summer and winter softens. Snow that falls in winter may linger through the year, building layers of ice that reflect sunlight back into space. As more light bounces away, the planet cools further, creating a self-reinforcing cycle that leads to an ice age. When the tilt increases again, sunlight returns with greater strength, melting the ice and ushering in warmer ages. These cycles are etched into stone and ice, preserved in ancient sediments, fossils, and bubbles of air trapped within glaciers. They tell the story of a planet whose climate has never been still, always swaying gently between extremes. Each cold gust and each warm breeze is part of a vast, ongoing conversation between Earth and the Sun, written in the language of motion and light. Among the most graceful markers of this rhythm are the equinoxes, the fleeting instants when the Sun crosses directly over Earth's equator. Though many people think of the equinox as a whole day, it is in fact a single moment when the planet's axis tilts either toward nor away from the Sun. For that brief instant, day and night appear nearly equal across the globe. This balance happens twice a year, in March and September, and has long symbolized harmony and renewal. Ancient civilizations marked it with temples, pyramids, and celestial calendars. To stand beneath that sky is to feel a rare symmetry, as though the universe itself is pausing to breathe. Yet even that balance is fleeting. Within hours, Earth continues its endless motion, leaning again, and the long journey toward the next season quietly begins. But the equinox, for all its beauty, is never perfectly balanced. The Earth's atmosphere bends sunlight, an effect called atmospheric refraction, allowing us to see the sun several minutes before it actually rises and after it sets. This bending stretches daylight slightly longer than night almost everywhere on Earth. The degree of this bending changes with temperature, air density, and elevation, meaning that the perfect equality of light and dark never truly exists for everyone at once. Near the poles, where the sun hovers low on the horizon, the effect grows even more pronounced. The equality of day and night is, in truth, an illusion, a poetic distortion of light that makes the equinox feel magical. Yet perhaps it is precisely that imperfection that makes it so meaningful. It reminds us that balance in nature is never absolute. It is a momentary alignment, a breath of symmetry between two infinities. In this eternal cycle, tilt and orbit, warmth and cold, darkness and light, the Earth finds its rhythm. Seasons whisper of change, but also of return. Each winter's silence contains the promise of spring. Each summer sunset hints at the cooling of autumn. Our ancestors watched these patterns to plant, to harvest, to hope. Today we track them with satellites and data, but the feeling remains the same, awe before the harmony of motion that sustains us. The seasons are not just markers of time, they are the expression of a living planet, a cosmic rhythm that threads through oceans and forests, through hearts and tides. And as you drift into rest, listening to this quiet science of light and shadow, remember that the same gentle tilt that turns the Earth also turns your world, softly, endlessly, toward renewal. The word solstice comes from the Latin solstitium, meaning, the sun stands still. And it marks a profound celestial moment when the sun's path across the sky appears to pause before reversing direction. Around this time, sunrise and sunset positions change so slowly that the sun seems to linger, as if taking a breath between seasons. The ancients saw this pause as sacred, a time when the heavens themselves held still. The June solstice brings the longest day of the year to the northern hemisphere, while December delivers the shortest, and for millennia, civilizations have celebrated these turning points as the symbolic death and rebirth of light. Fires were kindled, monuments aligned with the rising sun, and stories told of renewal and return. Even now, modern festivals and rituals honor that brief stillness when the rhythm of the cosmos seems to slow. The solstice, beyond its scientific meaning, is humanity's oldest clock, a time when we feel most deeply connected to the slow turning of the heavens. The apparent pause happens because of Earth's tilt and its orbit around the sun. Each day, the sun rises and sets at slightly different points along the horizon, but near the solstice, that motion nearly stops, so that for several days the difference from one sunrise or sunset to the next is imperceptible. Then, gradually, the sun's path begins to shift again, marking the return of light's journey toward the opposite hemisphere. To ancient observers, this was mystical proof that the sun itself could rest before beginning anew, but today we know it as the graceful outcome of celestial geometry. Still, the feeling it inspires remains powerful. The idea that even in the grandest cosmic motions, there are moments of calm, pauses that mark renewal and change. In that stillness lies the quiet heartbeat of the year, the instant when one season bows to the next and the eternal cycle begins again. Long before mechanical clocks or calendars, the sun was our first and greatest timekeeper. Ancient civilizations used solstices to mark the turning of the year and the rebirth of light. The sun's path revealed the rhythm of existence itself, the pulse of life and death, growth and rest. When the days reached their shortest point, observers noticed the light hesitate, then begin to return. That rebirth became the anchor for rituals, harvests, and myths. The winter solstice symbolized the death of darkness and the promise of renewal. The summer solstice represented the peak of vitality and abundance. Fires were lit to call back the light, and stones were raised to frame the dawn. From Egypt to China to the Americas, humanity found meaning in this same celestial rhythm. Solstices were more than seasonal markers. They were profound reminders that even the longest night eventually gives way to dawn, that change is the only constant, and that the sun always keeps its promise to rise again. The ancient monuments that still stand today, Stonehenge in England, Machu Picchu in Peru, and Chaco Canyon in New Mexico, bear silent witness to this shared human wonder. Across continents and centuries, people built massive structures aligned precisely with the solstice sunrises. At Stonehenge, the first rays of midsummer dawn strike directly through the great stones, filling the inner circle with golden light. At Machu Picchu, the Incas carved sidelines so that the winter solstice sun shines perfectly through a temple window, illuminating a sacred stone. In Chaco Canyon, spirals etched into cliffs mark the solstice with narrow beams of sunlight that pass through their centers for only a few fleeting moments each year. These constructions were not mere calendars, they were bridges between heaven and earth, transforming sunlight into architecture and time into something humans could touch. Each alignment was an act of reverence and awe, a gesture of humanity reaching upward toward the cosmos. The solstice also reveals another curious truth about our planet. During the northern hemisphere's winter, Earth is actually closest to the sun. It feels counterintuitive, but Earth's orbit is slightly elliptical, meaning our distance from the sun varies by about 5 million kilometers over the year. In early January, during the height of northern winter, our planet reaches perihelion, its closest point to the sun. Yet this distance makes almost no difference to temperature, because warmth is determined not by proximity but by the angle of sunlight and how directly it strikes the ground. In January, the northern hemisphere tilts away from the sun, spreading its light over a larger area and reducing its intensity, while the southern hemisphere faces the sun more directly and experiences summer. This asymmetry is why the two hemispheres experience opposite seasons. The small variation in distance does, however, make the southern hemisphere's summers slightly warmer and its winters milder, since it receives a bit more direct solar energy when Earth is nearer to the sun. Still, the difference is minor. Only about a 3% change in distance separates the farthest and closest points of Earth's orbit, far too little to create the dramatic contrast between summer and winter. The illusion of warmth due to proximity reminds us that the true architect of seasons is geometry, not distance. Seasons are driven by sunlight's angle, not our nearness to the sun. When the sun sits high overhead, its rays strike the surface directly, concentrating energy and warmth. When it sits low on the horizon, those rays must travel through more atmosphere and spread across a wider area, softening their intensity. This simple shift defines the rhythm of heat and cold, of summer's brilliance and winter's chill. Long days of direct sunlight bring warmth and life. Short days of slanted light bring rest and stillness. Even at the same distance from the sun, one hemisphere basks in sunlight, while the other slumbers in shadow. This shifting angle drives weather patterns, ocean currents, and the migrations of countless species. It influences the growth of plants, telling them when to bloom, fruit, and shed. The tilt of Earth turns light into rhythm, translating celestial motion into the living patterns of every day. Our seasons are not random. They are the elegant outcome of a planet tilted just enough to make life dynamic and diverse. The Arctic Circle marks the latitude where the sun never sets during the summer solstice. At the top of the world, there comes a day when the sun simply refuses to leave the sky. North of the Arctic Circle, the summer solstice brings 24 hours of daylight, an unbroken glow circling the horizon in quiet majesty. The sun drifts low but never dips below, bathing tundra and sea ice in perpetual light. This phenomenon, called the midnight sun, transforms ecosystems. Plants photosynthesize endlessly, birds nest and feed in constant brightness, and animals adjust their internal rhythms to a world without night. For humans, it is both wondrous and disorienting. Time feels suspended, sleep becomes elusive, and the boundary between day and night dissolves. Yet the same geometry that creates endless day also brings endless night 6 months later, when the sun vanishes completely for weeks or even months. In both extremes lies the power of Earth's tilt and orbit, shaping worlds that feel almost alien yet are entirely our own. At the opposite pole, within the Antarctic Circle, winter brings the reverse, a season of endless darkness. During the winter solstice in the southern hemisphere, the sun disappears below the horizon, leaving the icy continent in twilight or shadow for long stretches. Temperatures plunge, winds roar, and the ocean freezes into vast sheets of ice. Still, even in that stillness, life endures. Penguins huddle in tight circles for warmth, sharing body heat through brutal cold. Seals rest on the frozen surface, diving through cracks in the ice to hunt beneath. Microscopic algae bloom under the frozen sea, feeding on the faintest traces of light that filter through the ice. This unseen life sustains the entire polar food web. When the sun finally returns, the transformation is immediate and breathtaking. The ice gleams, the skies glow with color, and life surges back in an explosion of movement and sound. The endless night gives way once again to day, the eternal rhythm of return and renewal. These extremes remind us that our planet is a masterpiece of balance. Every tilt, every angle, every pause in the sun's path tells a story of connection between Earth and the heavens. The solstice, with its stillness and light, embodies that balance perfectly. It is a moment that unites science and spirit, geometry and wonder. The ancients saw in it a symbol of rebirth. Modern astronomers see in it the predictable beauty of orbital mechanics. Yet both perspectives point to the same truth, that change and continuity are woven together in the fabric of time. Whether we gather at ancient stones to watch the sunrise or simply notice how shadows lengthen across our own doorstep, we are participating in an ancient ritual that spans all of human history. Every solstice is both an ending and a beginning, a reminder that even in stillness, the world is turning. As the Earth continues its steady orbit, the solstice will come again, each one a gentle pulse in the heart of time. The sun will seem to pause, the light will waver, and life will respond as it always has, by adapting, by awakening, by resting, and by renewing. For the plants that reach toward the light, the animals that migrate by its cue, and the humans who mark their lives by its rhythm, the solstice is not just a moment in the sky, it is the turning of the world's soul. In that pause, that breath of sunlight at the edge of darkness, we are reminded of our place in the cosmic dance, of our connection to the vast and patient geometry that shapes everything we know. The sun stands still, the earth leans gently, and in that stillness, all of life listens, waiting for the light to return. When the sun finally returns to Antarctica after months of darkness, it rises in a low golden arc that paints the horizon with a glowing ribbon of light, a shimmering reminder that even the coldest and most remote place on Earth is bound to the rhythm of the heavens. The Antarctic day and night mirror the Arctic's extremes, opposite reflections born from the same celestial tilt. These cycles are nature's most dramatic expression of endurance and adaptation, teaching us that even in the deepest dark, light waits patiently to return. Yet even when the Antarctic sun circles the sky without ever setting, its warmth barely touches the frozen world below. The sun's rays skim the surface at such a shallow angle that they scatter and reflect off the brilliant snow and ice, sending much of their energy back into space. The air, thin and dry, cannot hold heat, and the result is a paradox: endless daylight but relentless cold. The landscape glows under the perpetual sun, its crystalline plains and glittering peaks bathed in radiance, yet the temperature rarely climbs above freezing. Scientists working through the Antarctic summer describe an eerie sense of contradiction: dazzling light, total visibility, and biting cold that cuts through every layer of clothing. It is a world where time seems suspended, where summer never truly arrives, and where the silence of the wind and ice carries the echo of the cosmos itself. In this luminous chill, one truth becomes clear: the angle of sunlight matters far more than its duration. Near the equator, the story is different. Here, the sun's path barely shifts throughout the year. Day and night remain almost equal in length, and the heat of the tropics rarely wavers. Seasons, as known in temperate regions, dissolve into something simpler and more elemental: the rhythm of rain and dryness, the breathing of the sky itself. In equatorial regions, it is water, not temperature, that dictates the pulse of life. The alternation between wet and dry seasons shapes the lives of plants, animals, and people alike. When warm air rises over sun-heated land and draws moisture from the ocean, rain clouds gather and burst in torrential downpours. When the air cools and sinks, the skies clear, and landscapes turn golden and brittle. This exchange is not random. It is the grand monsoon system, one of the most powerful and predictable patterns on Earth. Driven by sunlight and the uneven heating of land and sea, the monsoon is the planet breathing in and out. During summer, land heats faster than ocean, creating low pressure that pulls moist air inland, releasing vast amounts of rain. In winter, the land cools quickly, reversing the flow and bringing dry winds that sweep the moisture away. This immense cycle defines the rhythm of life for billions of people across Asia, Africa, and the Americas. It nourishes fields, fills rivers, and sustains ancient civilizations, but it also brings floods, storms, and hardship. The word monsoon itself comes from the Arabic mausim, meaning season, a testament to the deep understanding early sailors and traders had of the winds that govern their voyages. Long before meteorology, they read the sky as a living clock, learning to harness its rhythm for navigation and survival. The changing winds of the Indian Ocean carried spices, silk, and stories between continents, creating a network of trade that was as dependent on nature's cycles as on human ingenuity. For countless cultures, the monsoon is more than weather. It is a conversation between land, sea, and sky. Every year, it returns with near-perfect precision, reminding humanity of our dependence on the forces that move unseen above us. In many tropical regions, this dialogue reduces the year to two halves, wet and dry. Instead of 4 seasons, life pivots between abundance and scarcity, flood and thirst. The wet season transforms the world, turning dust to mud, plains to rivers, and air to mist. Plants burst into green fury, insects hum through the thick humidity, and the earth feels alive in every direction. As months pass, the rain retreats, and the dry season returns, stripping the land back to its essentials. Trees shed leaves to conserve water, animals migrate to shrinking waterholes, and human life adjusts. Harvests are gathered, journeys are timed, and patience becomes a form of wisdom. These shifts are not merely climatic but cultural, defining traditions, festivals, and myths that celebrate both the giving and withholding of rain. Even in the evergreen tropics, where life seems unchanging, subtle seasons still unfold. In the dense rainforests near the equator, where the canopy stretches endlessly toward the sky, variations in rainfall and humidity quietly guide the rhythm of existence. At first glance, these forests appear timeless, lush, green, and full of sound no matter the month, but beneath the surface lies an invisible choreography. Tiny changes in moisture determine which flowers open and which insects emerge, when trees drop fruit, and when birds build nests. Many trees release seeds only during peaks of humidity to ensure that their young will take root in moist soil. Frogs time their calls to the first heavy rains. Birds align their breeding with the explosion of caterpillars that feed on fresh leaves. Even the smallest creatures, ants, fungi, and bacteria, follow the hidden timetable of the atmosphere, rising and resting in sync with unseen fluctuations. The rainforest does not know winter or autumn in the temperate sense. yet it moves through a continuum of renewal and decay as constant as breathing. In the vast Amazon basin, where temperatures remain steady year-round, the sun's changing position in the sky still exerts quiet influence. Many Amazonian trees respond not to temperature, but to the quality of light filtering through the canopy. As the sun climbs higher in the sky, its rays pierce deeper into the forest, triggering bursts of flowering among species adapted to bright conditions. Others bloom when the light dims, avoiding competition for pollinators. This staggering of timing ensures that food sources are spread throughout the year, supporting an astonishing diversity of life. Bats, bees, and birds follow these botanical calendars with remarkable precision, migrating or nesting in rhythm with the forest's pulse. What appears as chaos, countless species acting independently, is in fact an intricate harmony orchestrated by sunlight. Even in the tropics, where the sun seems eternal, its slow migration across the sky writes the script for every leaf, every sound, every breath of wind. Beneath the waves, another world follows its own calendar. Coral reefs, among the most complex ecosystems on Earth, depend on the precise timing of light and warmth to survive. Once a year, in a spectacle so synchronized it seems miraculous, corals across entire reefs release clouds of eggs and sperm into the water simultaneously. The ocean fills with drifting spheres of color that rise and swirl like underwater snow. This mass spawning event is triggered by a delicate combination of cues: seasonal temperature peaks, lunar cycles, and the faint glow of the full moon. The synchronization ensures that millions of gametes meet at once, vastly increasing the odds of new life while feeding a multitude of creatures in the process. Fish, plankton, and even larger predators gather to feast on this temporary abundance. Scientists who witness the event describe it as the heartbeat of the reef, a rhythmic pulse that connects ocean and sky. The coral's awareness of season is not conscious, yet it is exquisitely precise, a reflection of how deeply life is attuned to the cosmos. From frozen deserts to tropical forests to coral seas, the turning of the earth and the dance of sunlight shape every form of existence. Even where we might least expect it, on the barren dunes of deserts, the seasons leave their mark. Seasonal winds sculpt sand into vast waves, shifting landscapes that seem eternal yet are in constant motion. These winds, born of temperature differences between land and sea, can move mountains of sand grain by grain, creating patterns that change with the seasons. In the Sahara, summer brings hot, rising air that fuels powerful dust storms, carrying fine particles across continents and even oceans. That dust, rich in minerals, fertilizes distant rainforests like the Amazon, linking two ecosystems thousands of miles apart through an invisible chain of wind and sunlight. In winter, cooler air stills the dunes, and the desert rests until the next cycle begins. The same planetary forces that drive monsoons and polar nights also shape the driest places on Earth, reminding us that every region, no matter how remote, is part of one vast, interconnected rhythm. From the freezing brilliance of Antarctica to the steaming jungles of the equator, from coral reefs that glow beneath moonlight to the deserts that breathe with the wind, all of Earth's rhythms are guided by the same simple truth: the planet tilts, turns, and listens to the sun. Every drop of rain, every gust of wind, every bloom of coral or tree owes its timing to that celestial geometry. The seasons are the language of light and motion, spoken differently in every corner of the world but always telling the same story: the endless dialogue between Earth and the sky. The monsoon's roar, the rainforest's hush, the polar sun's silence, all are verses in the same song. It is a song of balance and renewal, of cycles that sustain the fragile web of life. Even as humans measure time in minutes and years, the Earth measures it in the slow sway of its orbit, in the tilt of its axis, in the rise and fall of warmth and rain. The return of the sun to Antarctica, the pulse of the monsoon, the flowering of a tree in the jungle, all whisper the same message: that light and life are bound together, endlessly returning, endlessly reborn. Deserts may seem silent and unmoving, yet beneath their apparent stillness lies constant motion driven by wind and time. Entire continents of sand shift and breathe as seasonal winds change direction and strength, sculpting the land into a living canvas of crescents, ridges, and star-shaped dunes that wander slowly across the horizon. In some regions, these winds reverse completely between summer and winter, reshaping the same dunes again and again, as if rewriting the story of the Earth's surface each year. Each grain of sand carries with it a history of light, air, and motion, traveling hundreds of kilometers through currents born from the uneven heating of the land by the sun. These patterns, captured in the flowing shapes of the dunes, are nature's record of the planet's atmospheric heartbeat, a story written not in words, but in wind. From space, satellites observe dunes creeping forward meter by meter each year, proving that even the driest, most barren landscapes pulse with movement and life. Deserts breathe through their own slow language, shaped by the invisible hand of the seasons. High above them, far beyond the reach of any dune's shadow, the jet streams circle the planet like ribbons of air, guiding storms and weather systems around the world. These powerful atmospheric rivers form where warm tropical air collides with cold polar masses, creating narrow bands of high-speed wind that shift north and south as the Earth's tilt changes the seasons. In summer, the jet streams retreat toward the poles. In winter, they descend closer to the equator, dragging cold fronts, storms, and rain-bearing systems with them. The position and strength of these currents determine rainfall in Africa, snow in Europe, and hurricane paths across the Atlantic. When the jet streams become unstable or meander, weather patterns can stall, producing heat waves, floods, droughts, or blizzards that linger far longer than normal. Though unseen, this ceaseless flow of air acts as the planet's silent conductor, orchestrating the grand symphony of global weather, and weaving the energy of the seasons into every gust and cloud we feel below. Across continents and oceans, countless creatures depend on the same rhythms of sunlight and temperature that steer the winds. Migrating birds, for example, read the path of the sun across the sky as if it were a celestial map. As daylight lengthens or shortens with each passing season, it signals to them when to begin their journeys. They memorize the sun's angle relative to the horizon, adjusting their flight paths as they move through changing latitudes. Many species combine this solar navigation with an internal compass attuned to the Earth's magnetic field, enabling them to cross oceans and deserts with astonishing precision. For these feathered travelers, the changing seasons are not background phenomena. They are the very machinery of direction. The same planetary tilt that gives us winter and summer also paints invisible highways through the sky, guiding wings from one hemisphere to the other and back again. Beneath the waves, whales respond to similar seasonal cues. In the vast, seemingly timeless oceans, light and warmth still dictate the rhythm of life. As the sun climbs higher in spring and summer, plankton blooms erupt in temperate seas, feeding swarms of krill and fish. Great whales like the blue and humpback follow these food-rich waters, migrating thousands of kilometers each year to feast in polar seas during the summer, then returning to tropical lagoons in winter to breed and nurse their young. Their journeys, guided by the same tilt and orbit that shape the seasons, link the cold and warm ends of the Earth in a continuous circuit of life. Some species, like the Arctic tern, take this pursuit of light to the extreme, traveling from the Arctic to the Antarctic and back every year, chasing the sun so perfectly that they live in nearly endless daylight, experiencing 2 summers each year. Tracking devices have revealed that these tiny birds zigzag across the oceans to ride favorable winds, turning their migration into a masterpiece of precision. Over a lifetime, a single tern may travel a distance equivalent to flying to the moon and back several times. Their delicate wings trace the Earth's geometry in motion, proof that even a creature weighing less than a smartphone can navigate by the design of the cosmos itself. On land, larger creatures synchronize their lives with the same invisible clock. Bears, for instance, do not hibernate because of the cold alone. Their rhythm runs on light. As autumn approaches and daylight dwindles, hormonal changes signal the bears to begin their preparation. They feed tirelessly, gorging on berries, roots, and fish, doubling their weight in anticipation of the long sleep ahead. The shortening days slow their metabolism and eventually trigger the instinct to retreat into their dens. There, their body temperature drops, their breathing slows, and their heartbeats grow faint. In this twilight between wakefulness and sleep, mothers give birth in the depths of winter, nursing tiny cubs in the warmth of their still bodies. When the sun's light returns in spring, it stirs them awake, and they emerge once again into a world reborn. Their hibernation is not a retreat from winter but a perfect synchronization with the shifting rhythm of sunlight, a biological partnership with the cosmos that ensures survival in some of the harshest climates on Earth. Even smaller, more fragile creatures like monarch butterflies live by this same celestial metronome. Every year, millions of monarchs embark on a journey so vast that no single generation completes it. They begin in the northern United States and Canada, flying southward toward the mountain forests of central Mexico, where they cluster by the millions on fir trees to wait out the winter. Months later, their descendants, born in the warmth of spring, begin the long journey north again. Guided by the sun's position and the Earth's magnetic field, these butterflies navigate with a precision that still amazes scientists. Their migration ensures that they remain in a perpetual spring, avoiding both freezing temperatures and oppressive heat. It is a relay of life across generations, each new monarch inheriting not memory but instinct, following the same invisible trail of light across a continent it has never seen. Even the silent giants of the plant world, trees, respond to the same celestial cues. Deciduous trees mark the changing seasons not by temperature but by the length of the night. Specialized pigments in their leaves act like timekeepers, sensing when darkness exceeds a critical threshold. As nights grow longer in autumn, the trees begin to withdraw vital nutrients from their leaves, storing them in roots and stems for the cold months ahead. The veins sealing off each leaf form a thin layer of cells that eventually causes the leaf to detach and fall. What follows, the slow rain of gold, amber, and red across forests, is one of nature's most breathtaking spectacles, but it is not mere beauty. It is survival through precision. By shedding leaves, trees conserve water and energy, reducing damage during winter's freeze. When the days lengthen again in spring, they awaken in unison, sending up new buds in harmony with the returning light. This cycle, guided by photoperiod rather than temperature, ensures that forests across the globe remain synchronized with the turning of the earth. The colors of autumn themselves are a chemical reflection of sunlight and season. When chlorophyll fades, hidden pigments emerge, carotenoids revealing golden yellows and oranges, and anthocyanins creating the vivid reds and purples that ignite entire hillsides. Each tree species holds its own molecular palette shaped by genetics, temperature, and exposure to light. Cool nights intensify the reds by trapping sugars in the leaves, while warm, sunny days provide the energy needed to produce those pigments. The perfect balance, bright days and crisp nights, creates the most dazzling displays, as the leaves turn into stained glass windows for the sun. Overcast skies, meanwhile, dull the colors, softening the landscape into muted tones. Maples burn crimson, birches glow gold, and oaks fade into russet, each responding to the subtle interplay between chemistry and light. Scientists studying these transformations can identify species simply by analyzing pigment ratios under a microscope, revealing that the fiery symphony of fall is not random at all but an intricate, coordinated dance between biology and the sun. Cool nights and bright days bring forth the most vivid hues because they balance energy and restraint, the warmth needed for sugar production and the chill that locks those sugars in place. Too much heat and the colors fade prematurely. Too much frost and the leaves die before their transformation can unfold. In mountain valleys and northern forests where this delicate equilibrium often occurs, autumn paints the world with its richest tones. This phenomenon is more than just a seasonal show, it is the earth itself translating temperature, chemistry, and sunlight into color, a visible echo of the same cosmic rhythm that moves sand dunes, steers jet streams, guides migrations, and stirs the hearts of sleeping bears. From the smallest butterfly wing to the mightiest ocean current, everything moves to the same eternal pulse, the tilt of the earth, the angle of sunlight, and the never-ending passage of time written across land, sea, and sky in the language of the seasons. The colors of dry autumns glow so vividly because of the delicate balance between temperature, sunlight, and time, and each year's unique blend of these elements paints forests in hues that tell a story about that year's weather. The chemistry of every leaf captures this narrative, making each autumn both familiar and entirely new, a collaboration between light and life that repeats endlessly yet never produces the same scene twice. Some trees, like oaks, beeches, and hornbeams, delay the shedding of their leaves in a process called marcescence, keeping them through winter to capture the final rays of sunlight before the cold fully sets in. These lingering leaves continue limited photosynthesis, drawing in the last reserves of energy while also providing protection against frost and grazing animals or trapping snow that melts into the soil. When spring returns, the new buds push the old leaves aside in a graceful transition that shows how precisely evolution has tuned every organism to its environment. Even the timing of a leaf's fall is part of the planet's grand negotiation between sunlight, temperature, and survival. The scent of autumn, that earthy, nostalgic aroma filling forests and parks, does not come from the trees themselves but from the billions of microbes decomposing fallen leaves. As bacteria and fungi break down organic matter, they release molecules like geosmin and petrichor that blend with the moisture in cool air, creating one of nature's most distinct fragrances. These compounds are astonishingly potent, detectable by humans in concentrations of just a few parts per trillion, and they signify renewal rather than decay. Each inhalation of autumn air carries the chemical memory of summer forests transforming into fertile soil, a sensory reminder that the end of one season is the quiet preparation for the next. Spring begins when the sun crosses north of the celestial equator during the vernal equinox, an event not chosen by humans but dictated by Earth's orbit. At this moment, day and night are nearly equal across the globe, and sunlight begins its steady return to the northern hemisphere. Plants awaken from dormancy, animals emerge, and the balance of warmth and light shifts life back into motion. This astronomical crossing has guided human rituals and agricultural calendars for thousands of years, marking a time of rebirth and balance from ancient Persian celebrations of Nowruz to the myths that link it to fertility and renewal. Though invisible to the eye, the equinox defines the rhythm of life on Earth. Beneath frozen soil, early flowers like snowdrops and crocuses wait for the faintest hints of change, sensing warmth deep underground before the air above thaws. Their roots contain sensors that detect subtle increases in soil temperature, triggering biochemical signals that prepare the plant to grow while frost still lingers. This early emergence allows them to bloom before taller plants block sunlight, and before most insects awaken, ensuring they play a vital role as the first providers of nectar and pollen each year. These delicate flowers serve as the bridge between the silence of winter and the hum of spring, synchronizing perfectly with the planet's slow awakening. Plants measure time not through sight but through chemistry, using pigment molecules called phytochromes as their internal clocks. These molecules change shape depending on light exposure, transforming during daylight and reverting during darkness, allowing the plant to measure the length of night and thus determine the season. This subtle system regulates when seeds germinate, when flowers open, and when leaves fall. Artificial lights can disrupt this natural rhythm, confusing plants into blooming too early or delaying dormancy, revealing how deeply intertwined life is with sunlight's precise rhythm. Each sunrise resets this biological calendar, maintaining the Earth's cycle of renewal. As sunlight strengthens in spring, it warms the ground and stirs soil microbes back to life. These organisms begin decomposing organic matter, releasing nitrogen compounds in a process called mineralization. This nitrogen becomes available to grasses and other plants, triggering rapid growth. Hills and fields that were brown and lifeless through winter suddenly flush green, a transformation driven by the invisible labor of bacteria and the power of the returning sun. Rain spreads nutrients deeper into the roots, amplifying the burst of growth that feeds grazing animals and ripples through entire ecosystems. The greening of the earth each spring, so familiar and yet miraculous, begins not in the sky but in the microscopic interplay beneath our feet. Bees, too, rise in harmony with this awakening world. Their internal clocks are tuned to the same cycles of light and temperature that guide flowering plants. When blossoms open, they release scents that signal nectar readiness, calling bees from their winter dormancy. This synchrony, flowers blooming when bees awaken, is the result of millions of years of coevolution. Each pollination sustains not only the bees and the plants but entire food webs dependent on them. Even slight disruptions caused by climate change can desynchronize this delicate relationship, leaving flowers unpollinated and bees without food. The gentle hum of bees across spring meadows is the sound of nature's timing made audible. In colder regions, wood frogs perform one of nature's most astonishing feats of survival. They freeze solid during winter. As temperatures drop, their hearts stop, and their blood turns to ice, yet they do not die. Glucose and urea flood their cells, preventing ice crystals from puncturing tissues, preserving them until warmth returns. When spring sunlight thaws the forest floor, they slowly awaken, their heartbeat resumes, lungs inflate, and within days, they're singing from meltwater pools, continuing the cycle of life that depends on seasonal rhythm. Their frozen stasis and rebirth mirror the planet's own seasonal heartbeat. Light itself acts as the master conductor of life's timing. When sunlight enters the eyes of animals, it travels through neural pathways to the brain's pineal gland, influencing the production of melatonin, the hormone that regulates sleep, activity, and reproduction. Long summer days lower melatonin levels, triggering wakefulness and mating behavior, while short winter days raise it, prompting rest or hibernation. This rhythm operates across nearly all animals, from migratory birds and spawning fish to hibernating bears and even humans, binding life to the turning of the planet. The shortening and lengthening of daylight is not merely an environmental shift, it is the pulse of biology itself, driving migrations, breeding, feeding, and rest. The return of light after the long sleep of winter is a silent command felt across every level of existence, from the tiniest microbe to the largest whale. Spring, therefore, is not simply a season but the Earth's grand awakening, a living response to the geometry of the sun and the steady tilt of the planet, an eternal promise that after darkness, warmth and growth will always return. In temperate regions, animals rely on subtle shifts in sunlight and temperature to prepare for the changing seasons, adjusting their behavior, metabolism, and even appearance in tune with the Earth's orbit. They store fat for insulation and energy, grow thicker coats, or change fur and feather color to match the transforming landscape. Beneath these visible changes lies a profound harmony. The body's chemistry flows in step with the skies. The length of daylight, more than the temperature itself, dictates the rhythm of life. When the sun's arc lowers and days shorten, an invisible cascade begins. Hormones rise and fall like tides, guiding hibernation, migration, and the timing of reproduction. Even artificial illumination, though seemingly mild, can confuse these delicate cycles, disorienting migrating birds, sea turtles, and even humans whose sleep and mood depend on light. The alternation between long days and long nights is more than a backdrop of time. It is the hormonal heartbeat of the biosphere, a clock that has kept perfect time since life began. Every creature, from the smallest plankton to the largest mammal, carries a molecular rhythm entrained to the turning of the Earth. Though humans now live under electric light and within temperature-controlled walls, our bodies still obey the sun's rhythm. As winter shortens the days, melatonin production rises earlier in the evening, coaxing drowsiness before night fully falls. Serotonin levels may dip as sunlight wanes, drawing down energy and mood. Come spring and summer, when the days grow long and bright, melatonin fades later and serotonin blooms, lifting spirits and sharpening alertness. These ancient cycles live in the cells themselves, circadian clocks that adjust hormone release, body temperature, and metabolism to match the season's pulse. Long ago, humans marked these natural ebbs and flows with festivals of light, especially during the darkest times of the year, to call warmth and hope back into the heart. Even today, something as simple as early morning sunlight on the skin can reset the body's rhythm, restoring calm and focus. Though civilization may have dimmed the stars, our biology never forgets the language of dawn and dusk. Every sunrise still whispers the same command to our cells that it did to the first life in the oceans: awake, live, breathe. The scent of spring rain is another echo of this eternal connection. When the first drops fall after long dry months, a familiar, almost electric fragrance rises from the ground, a perfume of renewal. That scent, known as petrichor, comes from soil bacteria called actinomycetes that release spores during dry periods, waiting patiently for moisture. When rain finally touches the parched earth, the droplets dislodge those spores and release a molecule called geosmin into the air. Humans are extraordinarily sensitive to geosmin, able to detect it at just a few parts per trillion. Its smell signals life's return, a reminder that the soil still breathes. This emotional power runs deep in our memory, imprinted from ages when our ancestors depended entirely on the land's rebirth each spring. To breathe in the fragrance of fresh rain is to inhale history itself, the microscopic evidence that the long sleep of winter has ended and the world is stirring awake once more. As spring gives way to summer, the energy of the planet builds toward a crescendo. Lightning flashes through the sky about 8 million times each day, the Earth's most dramatic display of power and balance. Warm air surges upward, forming towering cumulonimbus clouds that churn with invisible tension. Inside them, ice crystals and droplets collide, separating charges until the atmosphere can hold no more. In an instant, the tension releases as a bolt of lightning, traveling faster than the human eye can follow, heating the air to tens of thousands of degrees and splitting the silence with thunder. Each flash is a burst of chemistry, a sculptor of the planet's nitrogen balance. The immense heat splits nitrogen molecules in the air, which later combine with oxygen to form compounds that fall in rain, fertilizing plants. Lightning, fierce as it is, sustains life as much as it threatens it. These electrical conversations between sky and ground link energy, air, and soil in a cycle that has endured for eons. Summer's warmth also changes the air's invisible composition. As temperatures climb, air can hold far more water vapor, an exponential relationship that defines why summer feels heavy and humid while winter feels sharp and dry. Even when humidity readings show the same percentage, warm air contains vastly more moisture, a hidden reservoir waiting to condense. When that air rises and cools, clouds bloom and rainfall begins, releasing enormous energy that powers global weather systems. In the tropics, this process fuels the daily rhythm of afternoon rains, while in temperate regions it feeds thunderstorms and summer showers. The dense, damp weight of midsummer air is not stillness but potential, the atmosphere charged with the promise of rain. When temperatures fall again, the vapor condenses or dissipates, and the sky clears. This delicate balance of heat, light, and water is the breath of the planet, cycling endlessly to shape each season's texture. Summer storms do more than rumble across the horizon, they help balance the Earth's climate. Every thunderstorm transfers heat from the surface upward, where high-altitude winds redistribute it toward the poles. This natural mechanism prevents runaway temperature extremes. Without it, the equator would grow unbearably hot and the poles ever colder. The thunder we hear is the sound of balance being restored. Even destruction serves creation's purpose, as energy disperses and the planet maintains equilibrium. The same roaring clouds that frighten with their flashes are the Earth's way of breathing, exhaling warmth from crowded tropical skies toward the frozen edges of the world. Beneath these storms, the oceans churn with equal purpose. Their vast conveyor belts of current shift subtly with the seasons, steering heat, moisture, and life itself around the globe. Winds rising from continents tug at the sea's surface, altering the direction and strength of major currents. In summer, intensified trade winds drive warm water poleward, while winter's calmer breezes let cooler, nutrient-rich water well upward from the deep. These movements shape entire ecosystems, dictating where fish spawn, where rains fall, and where deserts form. The Asian monsoon, the hurricanes that sweep the Atlantic, even Europe's mild winters all trace their origins to the ocean's shifting breath. Watching a single wave roll ashore is to glimpse the planet's distant heartbeat, a rhythm that travels for thousands of miles across water. Yet every few years, that heartbeat changes its pace. The Pacific Ocean undergoes a vast oscillation known as El Niño and La Niña, alternating patterns of warmth and coolness that rewrite the world's weather. When surface waters near South America grow warmer than usual, the trade winds weaken, and an El Niño forms. This single event ripples outward to cause floods in the Americas, droughts in Asia, and shifts in the paths of storms across the globe. Marine life suffers as upwelling currents falter, starving fish and coral reefs of nutrients. Eventually, the pattern reverses into La Niña, when cooler waters surge up and the trade winds strengthen once again, bringing rain to some regions and calm to others. These cycles, lasting 2 to 7 years, are the planet's climate heartbeat, pulsing through time and space with consequences for agriculture, wildlife, and human life alike. Even the ice at the poles joins in this grand rhythm. The world's great ice sheets, though appearing timeless, move in a slow dance of expansion and retreat with every passing year. As sunlight weakens during winter, snow accumulates faster than it melts, thickening the edges of glaciers. In summer, when sunlight strikes more directly, melting begins anew. From space, satellites reveal this annual breathing, ice fronts advancing and withdrawing like the tide, their rhythm echoing the planet's tilt. Though the total volume of ice remains mostly stable over short spans, these seasonal fluctuations subtly affect sea level, ocean salinity, and atmospheric circulation. The slow pulse of frozen water helps regulate Earth's entire climate system, influencing rainfall patterns and the global flow of heat. Every drop of melted ice that joins the sea, every storm that rises from the equator, every gust of wind or scent of rain is part of one unbroken cycle, the turning of seasons, written into every molecule of air and every cell of life. It is a reminder that the planet is alive not just in its creatures, but in its motion, its balance, its endless dialogue between light and dark, heat and cold, water and sky. Even in an age of artificial light and climate control, we are still bound to this ancient rhythm. Our hearts beat in time with the Earth's slow rotation. Our moods follow the arc of the sun. To live on this planet is to belong to its seasons, to be part of a story written not in words but in warmth, shadow, scent, and sound, a story that began long before humans looked up at the sky and will continue long after, as the Earth turns, breathes, and dreams its eternal dream. Even the coldest and most remote parts of our planet are alive with change, constantly responding to the delicate interplay between sunlight and shadow. Snow, often seen as still and silent, is one of Earth's most dynamic agents in regulating temperature and balance. Each winter, as snow spreads across continents, it transforms the world into a giant mirror, fresh snow reflecting up to 90% of incoming sunlight back into space. This phenomenon, known as albedo, helps cool the planet by preventing solar energy from being absorbed by darker ground surfaces beneath. When snow cover grows, global temperatures drop further, reinforcing the cold in a natural feedback loop that maintains climatic stability. Yet when spring warmth returns and snow melts, the exposed Earth absorbs sunlight once more, beginning a new cycle of warming. The presence or absence of snow is far more than a matter of beauty, it is a thermostat for the entire planet. The Arctic, Antarctic, and high mountain ranges play a silent but critical role in this balance. Each glittering field of snow, made of countless ice crystals, reflects sunlight, preserving equilibrium in Earth's energy budget. When these snowy expanses shrink even slightly, the effect ripples outward, amplifying warming trends worldwide. A single snowflake begins its journey high in the sky, formed around a microscopic particle of dust, pollen, or volcanic ash drifting through the atmosphere. Water vapor condenses upon these tiny specks, freezing layer by layer into intricate crystalline patterns. Each flake is unique, shaped by humidity, temperature, and the nature of the particle at its core. Sometimes, the dust within a snowflake may have traveled thousands of miles, perhaps from the Sahara Desert or the ashes of a distant eruption. When such a flake finally lands on the ground, it carries with it a trace of global connection, a record of Earth's breath made visible. Snow, in this sense, unites Earth and sky, the microscopic and the immense, every flake a messenger of planetary motion. The creatures that live among these frozen landscapes have synchronized their lives to this rhythm of ice and thaw. The polar bear, a symbol of the Arctic, is entirely dependent on the seasonal pulse of sea ice. In the long winter, when the ocean freezes solid, polar bears roam vast expanses of ice in search of seals that surface through breathing holes. Each successful hunt builds the fat reserves that will sustain them through the sunlit months ahead. When summer arrives and the ice retreats, the bears lose their hunting grounds and must fast for weeks or even months, surviving solely on stored energy. This cycle of abundance and scarcity has repeated for countless generations, but now it teeters on the edge of disruption. As global temperatures rise and the frozen season shortens, the bears must travel farther across thinning ice to find food, expending precious energy. Their entire existence is written in the fragile geometry of ice, one that melts a little earlier each year. From the vastness of orbit, the frozen oceans tell their own stories. sea ice forms mesmerizing patterns that trace the invisible movement of wind and current. Long, swirling lines mark where the ice has fractured and drifted. When strong winds push against the surface, they compress sheets of ice together, forming jagged ridges that rise above the horizon. In calmer times, smooth layers of new ice, known as frazzle, form delicate glass-like sheets that glide silently across the water. Each texture and pattern encodes a story of forces at play: the strength of the wind, the temperature of the air, and the shifting of the tides. As seasons change, the surface transforms again. Turquoise melt ponds bloom in the spring sunlight, and as autumn returns, they freeze into dark, glassy pools. Scientists who study these surfaces can read them like a language of motion, deciphering how the atmosphere and ocean interact year by year. Even beneath the ice, life adapts to the seasonal rhythm in remarkable ways. Many fish species undergo transformations that mirror the turning of the year. As light and temperature shift, coral reef fish brighten their colors to attract mates during breeding seasons, while Arctic fish fade into darker tones to blend with the seafloor once ice retreats. Some species, such as certain wrasses and groupers, go beyond color changes. They can even alter their sex depending on the season. Hormones triggered by environmental cues dictate these transformations, ensuring that reproduction continues despite environmental challenges. When winter brings cold and scarcity, metabolism slows, activity drops, and colors dull. But when warmth returns, so does vitality, and the ocean becomes a theater of vivid hues once more. The seasonal transformations of the underwater world mirror those of forests shedding leaves or flowers blooming on land, every creature attuned to the same universal clock that governs when to feed, when to rest, and when to transform. Above these oceans, the sky itself joins in Earth's seasonal symphony. The northern lights, or aurora borealis, blaze most brightly during the equinox months of March and September, when Earth's magnetic field aligns most directly with the incoming solar wind. Streams of charged particles from the sun cascade toward the poles, colliding with atoms in the upper atmosphere. These collisions release energy as shimmering curtains of light that ripple in shades of green, violet, and crimson across the heavens. The spectacle is so vast that astronauts can see glowing rings encircling the poles from space. The changing intensity of the aurora across the year reveals another layer of seasonal rhythm, one not felt in temperature, but seen in light. Even the colors of the night sky move in harmony with the planet's tilt, the invisible geometry between the Earth, the Sun, and the magnetic field weaving a luminous rhythm that connects the heavens to our world below. Long before modern science, ancient civilizations recognized and revered these celestial patterns. Without clocks or digital calendars, early humans measured time through the sky. Across the world, from Egypt to Mesoamerica to China, calendars were based on the solstices and equinoxes, the four pivotal moments when the sun reached its extremes or achieved perfect balance. These astronomical events divided the year into natural quarters, marking the points when daylight was longest or shortest and when day and night stood equal. For agricultural societies, this knowledge meant survival. Farmers relied on the sun's cycles to know when to plant and when to harvest. But the celestial rhythm held deeper meaning as well. To many cultures, the solstices symbolized death and rebirth, while the equinoxes represented balance and renewal. Ancient temples were often aligned so that beams of sunlight would pierce their chambers precisely on these days, turning architecture into living calendars. The Great Pyramids of Egypt, the temples of Angkor, and the monuments of Stonehenge all mark humanity's enduring relationship with the movement of the sun. Even today, calendars such as the Persian, Hindu, and Chinese still align festivals and New Year's with these celestial milestones, carrying forward a 10,000-year-old tradition of honoring the sun's path. Archaeological discoveries continue to reveal just how early humans learned to read this cosmic language. In Scotland, researchers uncovered a field of ancient pits arranged in a sweeping arc that tracked the phases of the moon more than 10,000 years ago, older than any written record. The remarkable alignment of these pits with the rising sun at the winter solstice suggests that the people who built them understood not only lunar months, but also their relationship with solar seasons. They synchronized two rhythms, the cycle of the moon and the cycle of the sun, to create one of the world's earliest known calendars. This dual system allowed hunter-gatherers to anticipate animal migrations, the sprouting of plants, and the return of key food sources. Long before the invention of writing or farming, humanity was already charting the dance of light and shadow that governed life on Earth. The soil itself became a tablet for the first calendars, recording humanity's awakening to the passage of time. In later eras, early farmers refined this celestial awareness using simple but ingenious tools. They tracked the length and direction of shadows cast by standing stones, poles, or trees, marking the changing position of the sun through the year. When shadows grew shortest, they knew the summer solstice had arrived. When they stretched long again, winter was near. These natural sundials became both timekeepers and seasonal guides. By watching the movement of a shadow across a marked stone or along a line in the ground, farmers could tell when to plant crops or prepare for harvest with astonishing precision. Some of these ancient observatories, such as those at Nabta Playa in Egypt or at Stonehenge in England, aligned perfectly with solstice and equinox sunrises, evidence of deep astronomical understanding. Across generations, the observation of the heavens connected communities to their environment and to one another. Time was not an abstract number. It was the movement of the sun, the tilt of the earth, the return of the rains, and the lengthening of shadows. This timeless relationship between humanity, sunlight, and the changing earth continues today, even as we surround ourselves with artificial rhythms. The seasons still mark our moods and guide the migrations of animals, the blooming of flowers, and the freezing of seas. Snow still forms from the dust of distant lands, sea ice still cracks and reforms with the wind, and the aurora still dances across the poles in perfect step with the planet's orbit. The story of the seasons is written in every element: water, light, air, and life, woven into a single unbroken thread that stretches from the dawn of time to the farthest future. It is a story of reflection and renewal, of energy endlessly cycling between sky and soil, of living creatures adapting to a world that never stops turning. From the shining crystals of snow to the glow of ancient stars, everything on Earth moves to the same rhythm, the rhythm of sunlight and shadow, the eternal heartbeat of the planet itself. The story of time and light is written not just in clocks or calendars but in the shadows and rhythms that shape civilization itself. What began as simple observations, how a shadow stretched across the ground, how a star rose at dawn, evolved into systems so sophisticated they governed empires. Early humans noticed that the changing position of the sun altered the length of shadows, and from these markings came the first form of measurement, long before written numbers existed. Farmers in ancient fields watched these patterns carefully, realizing that when shadows were shortest, the sun was highest and the season of planting had arrived. When the days shortened again, it signaled harvest and rest. Over generations, these shadow measurements developed into organized calendars, the foundation of all structured society. Each flicker of light and each moving shade carried meaning, a silent clock powered by the cosmos itself. The Egyptian civilization took this understanding further than any before them. Their entire way of life revolved around the Nile, whose annual flooding transformed dry desert into lush farmland. They learned that this life-giving flood coincided with the rising of Sirius, the brightest star in the night sky, appearing at dawn just before the summer solstice. From that celestial cue, they crafted a 365-day calendar, dividing the year into 3 seasons: Ake, the season of flooding; Parait, the season of growth; and Shimu, the season of harvest. Each season contained 4 months of 30 days, followed by 5 festival days dedicated to the gods. In their view, the heavens and earth were connected by predictable cycles. The Nile's pulse was not chaos but harmony, a divine rhythm that linked water, sunlight, and human survival. Through this sacred pattern, they turned arid land into a thriving empire and aligned human time with cosmic time. Across the ocean, the Maya civilization built entire cities as vast calendars of stone. Their architects designed temples and pyramids to capture sunlight at precise moments, so exact that at Chichen Itza, the pyramid of Kukulkan transforms during the equinox. As the sun sets, light and shadow form the shape of a serpent slithering down the staircase, representing the return of the feathered god. This breathtaking phenomenon was not merely decoration but an instrument of astronomy, a monument of faith and geometry combined. Each Mayan structure was positioned to mark the sun's movement and guide agricultural and ceremonial events. They lived by a calendar more accurate than any used in Europe until modern times, measuring not just days and years but the spiritual rhythm between heaven and earth. For them, time itself was sacred, a living cycle that repeated endlessly through light, harvest, and rebirth. High in the Andes, the Inca honored the same celestial dance through the festival of Inti Raymi, the celebration of the sun's return after the winter solstice. Each June, when the longest night ended and the days began to grow, the people of Cusco gathered to greet the dawn. They extinguished every fire before sunrise, then relit them using the first rays of light reflected from golden mirrors, symbolizing the rebirth of warmth and life. Offerings of corn, llamas, and gold were made to thank the sun for its light, which brought fertility to their mountain valleys. Even today, centuries after the fall of the Inca Empire, descendants still celebrate this ritual, proving that humanity's connection to the sky is as emotional as it is practical. The festival is a reminder that every winter yields to spring, that light always returns after darkness, and that survival itself depends on honoring these rhythms. Yet while people mark seasons on human scales, the earth itself followed slower, grander cycles that unfold over tens of thousands of years. Our planet's path around the sun is not perfectly circular but slightly elliptical, and its axis wobbles and tilts like a spinning top. These subtle variations, changes in orbit shape, axial tilt, and precession, are known as Milankovitch cycles, named after the Serbian scientist Milutin Milankovic who first described them. Over vast timescales, these cycles alter how sunlight reaches different parts of the Earth, shifting climates, triggering ice ages, and thawing them again. When the tilt reduces or the orbit stretches, summers grow weaker, glaciers expand, and entire continents freeze under sheets of ice. When the cycles reverse, warmth returns, and forests reclaim the land. These celestial mechanics operate far beyond human perception, yet every snowfall, every ocean current, and every whisper of wind carries their signature. They remind us that our seasons are merely short notes in a symphony that spans millions of years, a cosmic heartbeat echoing through ice, rock, and time. Even today, differences between hemispheres bear the imprint of these ancient rhythms. The southern hemisphere, blanketed mostly by ocean, experiences gentler seasons because water absorbs and releases heat slowly. Australia, South America, and the southern oceans bask in a steady equilibrium, where summers are cooler and winters milder. In contrast, the northern hemisphere, dominated by continents, heats and cools rapidly. Its land masses amplify extremes, scorching summers and bitter winters, storms and snow, the dramatic pulse of life and dormancy. This imbalance shapes not only weather but also biology, the migration of birds, the greening and fading of forests, and even the patterns of human settlement. The land-heavy north breathes with stronger seasonal rhythm, while the watery south hums in steady calm. The Earth's elliptical orbit deepens this contrast further. Because our planet moves faster when it is closest to the sun, around early January, the northern hemisphere's winter is shorter than its summer. Conversely, the southern hemisphere's summer, occurring when Earth is farthest from the sun, lasts longer but is slightly cooler. The difference is subtle, only a few days, but its consequences ripple through climate systems, influencing ocean currents, monsoons, and vegetation cycles. Over thousands of years, gravitational pulls from other planets slowly shift this ellipse, trading the longer summer from one hemisphere to the other. Even the length of a season is not fixed but gently sculpted by the invisible mathematics of celestial motion. Currently, the northern hemisphere enjoys a slight advantage. Its summer lasts about 4 days longer than the southern one. This imbalance affects everything from sea temperatures to atmospheric circulation, and though imperceptible day to day, it adds yet another rhythm to the planet's intricate choreography of light and heat. Across the equator, the dance continues in opposite directions. When one hemisphere leans toward the sun and basks in warmth, the other tilts away and sleeps in cold. The two halves of the world are bound together in perfect opposition, mirror images linked by a single invisible thread. This symmetry is the essence of the seasons, a balance between darkness and light, growth and rest, warmth and frost. Every snowfield glittering beneath the polar sun, every blooming meadow, and every harvest field owes its existence to that 23.5-degree tilt. Without it, Earth would know no seasons, no migration of life, no cycle of renewal. Humanity's oldest stories, from Egypt's floods to the Inca's fires, were attempts to understand and honor this cosmic geometry. The same tilt that paints auroras in the sky and shapes the flight of birds also carved the rhythm of civilizations. The shadow of a stone in the desert, the rising of Sirius at dawn, the golden serpent descending a Mayan pyramid, all are expressions of the same truth, that light and darkness move in eternal balance. From the turning of planets to the beating of hearts, everything that lives does so in time with that rhythm. Seasons are not just changes in weather, they are the language of life, the pulse of Earth's journey through space, and the memory of every sunrise that has ever touched this world. The two hemispheres of Earth exchange their roles every 6 months, trading warmth and cold in a rhythmic balance that helps maintain the planet's overall climate stability. The equator serves as an invisible yet powerful dividing line, where sunlight remains nearly constant throughout the year, creating a continuous equilibrium between north and south. From the vast perspective of space, this delicate dance appears as a slow, pulsating wave of brightness that shifts northward and southward with the passing seasons. Every gust of wind, every swirling current, and every storm that gathers across oceans participates in this grand planetary oscillation. The hemispheres are not true opposites but rather partners in motion, two halves of one living world revolving gently beneath the same golden sun. For countless migrating animals that cross this equatorial divide, the experience is like stepping through a mirror of time, where seasons, temperatures, and even the length of day reverse in an astonishingly symmetrical rhythm. Birds, whales, and even delicate butterflies embark on epic journeys that take them across the equator, moving through a cycle that mirrors the heartbeat of Earth itself. The cues that guide them, daylight, temperature, food availability, shift direction as they travel, yet evolution has gifted them an extraordinary ability to interpret and adapt to these changing signals with exquisite precision. Whales, for example, feast in the nutrient-rich waters of the Arctic or Antarctic during the summer months, then migrate thousands of miles to tropical seas to give birth in the opposite hemisphere's warmth. Certain seabirds perform similar odysseys, chasing endless daylight around the globe, creating a living connection between the hemispheres and weaving an invisible biological thread that ties north and south together in an endless seasonal conversation. In many cultures near the equator, where the intensity of sunlight hardly varies, time is not divided into 4 familiar seasons but into many smaller, subtler cycles. Some equatorial communities recognize up to 6 microseasons each year, each defined not by temperature but by rainfall, wind patterns, or the blossoming and ripening of certain plants. These short seasons may last only a few weeks, but they are deeply significant, shaping agricultural cycles, rituals, and traditions. In East Africa, fishermen mark the beginning of new periods by the arrival of the monsoon winds, while in Indonesia, farmers recognize dozens of transitional moments that guide planting and harvesting decisions. These microseasons are a form of environmental literacy, time measured not by clocks or calendars but by the language of nature itself. The Japanese once developed a similar way of reading the world's subtleties, dividing the year into 72 miniature seasons known as Shichijuni-ko, each lasting about 5 days. These fleeting intervals capture delicate transitions in the natural world, moments when east winds melt ice, when frogs begin to sing, or when bamboo shoots first pierce the soil. Originating from ancient Chinese observations and later refined by Japanese poets and scholars, this calendar celebrates impermanence and invites people to notice the smallest details around them, the scent of plum blossoms, the deepening hue of rice fields, or the subtle change in a bird's song. Though modern Japan follows the solar calendar today, these poetic divisions still appear in art, literature, and almanacs, serving as gentle reminders to live in tune with nature's unfolding conversation. Similar wisdom can be found in Australia's indigenous cultures, where calendars are not based on months or temperature, but on the behavior of plants, animals, and the land itself. Each region defines its own seasons based on ecological events. The Yolngu people of Arnhem Land, for instance, recognize 6 distinct seasons, one heralded by the arrival of dragonflies, another by the ripening of bush plums. In the desert interior, the Pichinchachara people observe the shifting of winds and the seeding of grasses to track the passage of time. These are not abstract or symbolic systems. They are deeply practical, teaching communities when to hunt, gather, and rest. They represent one of humanity's oldest and most sophisticated relationships with the environment, a living calendar written directly into the patterns of the land. Even in modern Australia, indigenous seasonal knowledge remains some of the most accurate and ecologically grounded understanding of climate and environmental change. Far to the north, in Finland, the long transitions between seasons are stretched into luminous twilight. Here, spring lingers in a haze of pale gold that never quite fades into darkness, and autumn glows in a melancholy cascade of color known as ruska. This word captures both the visual beauty of changing leaves and the emotional tone that comes with impermanence, the gentle sadness and wonder of transformation. Festivals in Finland honor these threshold moments, when daylight begins to return or retreat, and people gather to watch the slow dance of the sun along the horizon. In midsummer, the sun barely sets, bathing the landscape in a soft perpetual dusk, while in winter, it only traces a low arc before disappearing into a long polar night. Life in these latitudes becomes a kind of breathing, an inhalation of light followed by an exhalation of darkness, each cycle celebrated as a natural miracle. The spring equinox, too, reveals the planet's intricate relationship with time. Scientifically, it is a single moment, when the center of the sun crosses the celestial equator, but because Earth is divided into 24 time zones, that moment does not happen everywhere at once. Depending on where you stand, the equinox might occur on March 19th, 20th, or 21st. Astronomers can pinpoint it to the exact second, yet for most people, it is felt more than measured. A brief pause when day and night balance perfectly before tilting once more toward either light or shadow. This invisible wave of equilibrium sweeps westward across the globe, a silent ripple of harmony that connects every living being under the same sun. Even in the most remote corners of the Earth, the seasons tell stories of adaptation and change. On the Antarctic Peninsula, the world's coldest continent has begun to show a surprising and sobering transformation. As global temperatures rise, small stretches of once frozen ground now thaw briefly during the short polar summer, revealing pockets of soil where mosses and algae bloom into bright green carpets. For a few fleeting weeks, these fragile plants photosynthesize under the midnight sun, creating what scientists call the continents. Green lungs. These oases of life are both wondrous and worrisome, signs of resilience in the face of change, but also warnings of a warming world. Some Antarctic mosses have evolved to survive nearly 10 months of complete darkness, storing sunlight as sugars and protective compounds that prevent them from freezing. During the long winter, they enter a suspended state where metabolism nearly stops, but when the first light of summer returns, they awaken instantly, resuming life as if no time had passed. Their extraordinary endurance offers insight into how life might persist on other icy planets, revealing the universal truth that survival often depends not on constant activity, but on knowing when to rest, when to conserve, and when to bloom. Meanwhile, beyond Earth, even our neighboring planet Mars tells a story of shifting seasons. Over millions of years, its axial tilt has changed dramatically, transforming its climate in ways that mirror Earth's ancient cycles. Scientists believe that during certain periods, Mars may have had warmer, wetter seasons, with rivers and lakes that flowed beneath its red sky. Today, as its tilt continues to evolve, the Martian poles grow and recede in great waves of frozen carbon dioxide, a haunting echo of our own seasonal rhythms. It reminds us that the pattern of balance and imbalance, of light and shadow, of growth and stillness, is not unique to Earth. It is woven into the very fabric of planetary motion. Taken together, these cycles, of hemispheres trading places, of whales and butterflies migrating, of moss waiting in ice, and of humans shaping calendars from wind and rain, reveal the profound unity of life and time. The seasons are not just measures of weather but expressions of existence itself. They teach patience, awareness, and the art of harmony with change. To watch the Earth breathe through its seasons is to witness a living system of perfect imperfection, endlessly balancing and rebalancing under the warmth of a single star. It is a reminder that every pulse of sunlight, every whisper of wind, every sprouting seed, and every moment of stillness belongs to one continuous rhythm, the great, unbroken heartbeat of the planet we call home. Mars, a world both familiar and alien, moves through cycles of change written not in days or years, but in eons. Unlike Earth, it lacks a large moon to stabilize its axial tilt, leaving its orientation to drift chaotically over millions of years. At times, the planet's axis stands nearly upright. At others, it leans more than 40 degrees. Each shift reshapes the Martian climate in profound ways. When the tilt grows steep, sunlight pours more directly onto the poles, thawing frozen carbon dioxide and releasing vast amounts of gas into the thin atmosphere, triggering temporary warming. When the tilt eases, the poles refreeze, locking the carbon dioxide back into ice and plunging the planet into deeper cold. The record of these ancient rhythms lies preserved in Mars's polar ice caps, layer upon layer of frozen memory, each band a page from a geological diary describing ages of warmth and frost. The ever-changing angle of sunlight sculpts the winds and drives the massive dust storms that sweep across its deserts, shaping dunes, valleys, and even the faint possibilities of liquid water that may once have flowed across its surface. Mars's climate, then, is a kind of cosmic heartbeat, slower and more fragile than Earth's, a rhythm that has endured long after its seas vanished, and its sky thinned to near nothing. Though Mars shares a similar axial tilt to our planet, its seasons unfold in harsher tones. The thin atmosphere, less than 1% as dense as Earth's, cannot hold heat, allowing warmth to escape almost instantly into the void of space. Even at the height of summer, temperatures can remain well below freezing, while nights plummet to extremes that would shatter metal. Frost forms each morning from carbon dioxide, not water, glistening on the rocks before sublimating away by midday. Each dawn begins with a whisper of ice and ends with a sigh of dust as seasonal winds sweep fine particles across the world, painting its surface in shifting shades of red, gold, and copper. At the poles, carbon dioxide snow falls in winter and evaporates in spring, creating colossal pressure changes that fuel planet-wide dust storms. Storms so vast they can engulf the entire globe for months. Mars's seasons show us what happens when sunlight shines upon a world almost without air, beauty without warmth, rhythm without comfort, motion in near silence. Jupiter, by contrast, stands as a world of immense stability when it comes to its axial tilt. Its spin is almost perfectly upright, leaning only about 3 degrees compared to Earth's 23. This nearly vertical orientation means that Jupiter experiences hardly any variation in sunlight over the course of its 12-year orbit. Its seasons, if they can be called that, are nearly indistinguishable. Yet Jupiter's atmosphere never rests. The absence of strong seasons does not mean stillness. It means that the planet's weather is driven by deeper forces. Beneath its colorful cloud tops, internal heat radiates from its massive core, fueling constant turbulence. This energy drives vast jet streams that divide the planet into alternating bands of light and dark clouds, each thousands of kilometers wide. The most famous of all, the Great Red Spot, has raged for centuries, a colossal storm larger than Earth itself, powered not by sunlight but by the restless convulsions of Jupiter's deep interior. Here, the climate is perpetual motion, a reminder that even worlds without a tilt or changing seasons can pulse with endless activity, governed not by the sun above but by the heat within. Saturn, the ring giant, moves more slowly through time. With a tilt similar to Earth's and a year nearly 30 times longer, its 4 seasons each last about 7 Earth years. As sunlight gradually shifts from one hemisphere to the other, subtle transformations sweep through its pastel-hued atmosphere. During Saturnian summer, the clouds of the illuminated hemisphere brighten, and the planet's delicate belts of color shift in tone, reflecting the gradual warming of its upper atmosphere. The majestic rings, composed of ice and dust, catch sunlight at changing angles, altering their glow from silvery brilliance to muted shadow. These variations unfold so slowly that even dedicated scientists must wait decades to witness a full cycle of seasonal change. Saturn's calendar reminds us how relative time truly is, how what feels fleeting to us can stretch across a human lifetime elsewhere in the solar system. Every 15 years, Saturn's tilt causes its rings to align edge-on with the Sun and Earth, making them nearly disappear from our view. In those rare moments, they vanish into a razor-thin line of reflected light, almost invisible against the blackness of space. As the years pass and the planet continues its orbit, the rings open again, revealing their full, magnificent span. This slow oscillation, a bowing toward and away from the Sun, gives Saturn a grace unlike any other, a celestial rhythm as elegant as a cosmic waltz repeated every 3 decades. Uranus, on the other hand, dances to a stranger tune. It spins almost on its side, its axis tilted more than 90 degrees, as though it were rolling around the Sun like a marble tipped over on the floor of the universe. This extreme tilt grants Uranus the most bizarre seasons in the solar system. For 42 Earth years at a time, one pole faces the Sun in unbroken daylight, while the other lies in continuous darkness, before the situation reverses. These immense spans of light and shadow reshape its atmosphere in spectacular ways. As sunlight finally reaches the darkened pole after decades of night, it awakens storms and shifting cloud patterns in the planet's pale blue haze. From Uranus's point of view, sunrise and sunset are events of geological duration, and the planet's long, slow transition from light to dark feels less like a year and more like an epoch. Scientists believe Uranus's strange orientation may be the scar of a colossal collision early in its history, a planetary trauma that forever changed the way it moves through space. Now, it exists as a world of duality, one hemisphere glowing serenely in light, the other cloaked in shadow, each waiting patiently for balance to return in the far future. Farther still drifts Neptune, the most distant of the major planets. With an orbit that takes 165 Earth years to complete, each of its seasons lasts more than 40 Earth years. Neptune tilts about 28 degrees, enough to give it seasons, but their transitions unfold so slowly that humanity has observed only a handful since telescopes were invented. Subtle changes in its methane-rich clouds reveal which hemisphere faces the Sun, and variations in brightness across its atmosphere hint at the slow, shifting balance of warmth and cold. Yet sunlight there is nearly 1,000 times weaker than on Earth, so the changes occur in glacial slowness, winds of unimaginable power sweeping through a world lit by faint, distant rays. On Neptune, time itself stretches. A single spring could last longer than the span of human history, and a single storm could rage for centuries. This frozen, azure planet teaches that even at the edge of sunlight's reach, the pattern of the seasons continues, whispering through the cold and dark with a patience only the cosmos can know. Beyond Neptune lies Pluto, the small and distant world once considered the 9th planet. Despite its isolation and size, Pluto experiences a surprisingly active seasonal cycle. As it approaches the Sun in its long, elliptical orbit, its frozen surface of nitrogen and methane begins to sublimate, turning directly from solid to gas, and forms a thin, temporary atmosphere. Hazy layers rise miles above its mountains, glowing faintly in the dim sunlight. When Pluto swings back into the outer dark, temperatures plummet, and those same gases condense and fall as frost, coating the surface once again. This breath-like rhythm, inhale and exhale, thaw and freeze, takes place over decades, synchronized with Pluto's 248-year orbit. Subtle shifts in color across its plains and peaks show where the cycles of ice and vapor are strongest, each hue a signature of seasonal transformation on a world billions of kilometers from the Sun. These distant rhythms remind us that even the smallest, coldest worlds breathe in their own way. The tilt and light that create spring and autumn on Earth reach all the way to Pluto's frozen heart, turning the outermost edges of our solar system into a realm where time is measured in centuries of change. And even beyond Pluto, in the uncharted vastness of space, exoplanets, worlds orbiting distant stars, experience seasons beyond anything our imaginations can easily contain. Some travel in elongated, elliptical orbits that carry them scorching close to their suns for brief intervals before flinging them back into the darkness of deep space for centuries. On these worlds, one side of the year burns with unimaginable heat, while the other sinks into ages-long winters. Others orbit unstable stars that flare unpredictably, bathing their surfaces in sudden bursts of radiation and warmth before fading again, creating climates that shift in ways no life could easily predict. Some planets, locked in slow orbits around faint red dwarfs, may experience springs and summers that last longer than the entire span of human civilization. Astronomers observe these distant worlds by watching tiny changes in brightness, tracing how the faintest flicker of starlight can reveal the rhythm of alien seasons. These patterns, written in light years and measured in centuries, show us that the forces that shape Earth's gentle balance of warmth and cold are universal. They stretch across the galaxy, sculpting climates and cycles in forms both strange and familiar. In the end, whether on Mars or Neptune, Saturn or some faraway exoplanet, the story of seasons is the story of sunlight and tilt, of how the angle of a planet's axis and its path around its star determine the rhythm of life and time. It is a cosmic language spoken across worlds, a whisper of light, a tilt of shadow, a recurring song of change that binds even the most distant planets to the same eternal dance. The color of distant skies, the breathing frost of frozen plains, the slow unfolding of alien springs, all remind us that the concept of a season is not confined to Earth but is woven into the fabric of the universe itself. Each world, no matter how near or far, participates in this celestial rhythm, a testament to the symmetry of nature and the endless creativity of the cosmos. Planets can shift seasonally as clouds and ices move, and even from light years away, astronomers can sometimes detect the changing hues of alien worlds. As exoplanets orbit their stars, subtle variations in reflected light reveal how clouds, storms, or surface ices shift with the seasons, painting an invisible yet observable rhythm of transformation. A world covered in methane frost may brighten as it freezes and dim as it thaws, while others display color changes as dust storms sweep across their continents, or as alien oceans reflect different angles of starlight. These distant, shimmering patterns help scientists infer the presence of atmospheres, weather systems, and perhaps even oceans beneath the glow. Observations of Neptune and Mars show similar color shifts within our own solar system, teaching us how to interpret these distant signs, as if every changing tint in the light from a faraway planet were the signature of its own seasonal rhythm, a silent pulse of transformation echoing across the darkness between stars. Our own Earth participates in this cosmic breathing, its seasonal carbon cycle visible from space as forests green and fade like the inhale and exhale of a living organism. From orbit, satellites observe our planet breathing each spring, when sunlight strengthens in the northern hemisphere and forests burst into life, absorbing carbon dioxide from the air. This vast photosynthetic surge lowers global carbon levels by measurable amounts, and in autumn, as leaves fall and decay, that carbon returns to the atmosphere. The effect is so immense that it creates a visible pulse in data collected by spacecraft, a planetary heartbeat synchronized with the rhythm of the seasons. In the southern hemisphere, with its smaller land masses, the effect is subtler, but together the hemispheres balance each other, forming an exquisite global equilibrium. Every shade of green on Earth contributes to this living cycle, each leaf playing a role in regulating climate and chemistry from space. The changing colors of the continents tell the story of a living world inhaling and exhaling with the turning of the year. In the northern hemisphere, where most of Earth's land and forests lie, the effect dominates. Each summer, as sunlight pours across this half of the world, forests inhale deeply. Trillions of leaves open their microscopic pores to the air, drawing in carbon dioxide and using its carbon to build sugars, fibers, and cells. The process is so vast that satellites can measure a steady drop in atmospheric carbon levels from May through August, proof of photosynthesis operating on a planetary scale. By late autumn, the process reverses. Leaves fall and decay, fungi and bacteria consume them, and the carbon-bound and living tissue returns to the atmosphere. The Earth exhales. Because most vegetation lies north of the equator, this hemisphere leads the rhythm, its great forests controlling the ebb and flow of air's chemistry. Each year, atmospheric carbon rises and falls by a few parts per million, a gentle but persistent heartbeat of life, proof that the forests breathe with the same precision as lungs, keeping the planet's air in balance for all living things. Every spring, a similar miracle unfolds across the oceans. As sunlight returns to high latitudes, the upper layers of the sea awaken. Cold water, mixed by winter storms, brings nutrients from the depths that feed an explosion of microscopic life. Phytoplankton, tiny algae floating near the surface, multiply by the trillions, turning entire swirls of the ocean faint green when viewed from satellites. Through photosynthesis, they absorb vast amounts of carbon dioxide, drawing it out of the atmosphere into the water. Some of that carbon sinks when plankton die, becoming trapped in deep currents for centuries, locking it away in the ocean's memory. These seasonal blooms are among Earth's most powerful regulators of carbon, rivaling even forests in their influence on global climate. They sustain entire marine ecosystems, feeding everything from krill to fish to whales, linking sunlight, chemistry, and life into one continuous chain. The ocean's springtime bloom is invisible from shore, but it is one of the most profound expressions of vitality on Earth, a silent, unseen breath that cools the planet and nourishes the deep. In autumn, the rhythm changes again. The crisp air carries the scent of decay and transformation. Trees shed their leaves, and the carbon captured through summer begins its return journey to the atmosphere. On the forest floor, fungi, bacteria, and insects break down the fallen matter, releasing carbon dioxide through the process of respiration. This slow exhalation balances the great inhalation of spring, forming a perfect loop of exchange. Some carbon lingers in the soil, stored in dark humus that enriches the earth for future growth, while the rest drifts skyward once more, blending into the air that encircles the planet. This ancient cycle has continued unbroken for millions of years, powering forests, soils, and climate alike. Every glowing pile of autumn leaves, every decomposing branch, is part of a global process, the renewal of nutrients and energy through decay. What appears to be an ending is merely another beginning, another turn in the planetary rhythm, as the Earth quietly exhales in preparation for its next breath. Even the technology orbiting Earth must bow to these same cosmic patterns. The planet's tilt not only creates seasons on the ground but also affects how satellites receive sunlight throughout the year. Those that rely on solar panels experience changing light intensity as their orbits shift relative to the sun near the solstices. Some spend longer in Earth's shadow, reducing the power available for instruments and communication. Engineers must plan for these variations carefully, adjusting battery cycles and scheduling operations to coincide with maximum sunlight. This delicate balance is not unique to Earth. Even spacecraft orbiting Mars face similar challenges as the seasons shift and sunlight angles change. Dust can coat their panels, light intensity fluctuates, and their power generation waxes and wanes just as life below does. Every orbiting machine becomes part of the same grand dance of tilt and light, a celestial rhythm that touches everything, from the roots of trees to the circuitry of satellites. The seasons even determine when humans can launch missions to other planets. Sending a spacecraft to Mars, for instance, requires perfect alignment between two moving worlds. Earth and Mars orbit the Sun at different speeds, so engineers must wait for a window when the two planets are positioned just right. These alignment opportunities occur roughly every 26 months, a repeating pattern that mission planners call launch windows. Like celestial seasons of opportunity. Launch too early or too late, and the spacecraft would require far more fuel to catch up to Mars, perhaps missing it entirely. Engineers calculate these alignments years in advance, aiming their probes so that the geometry of the planets and the path of sunlight align with exquisite precision. The same mechanics that bring spring to Earth also determine when a robotic explorer can leave home and begin its voyage across millions of kilometers of empty space. Even the International Space Station, circling Earth every 90 minutes, experiences its own version of the seasons. Astronauts aboard witness 16 sunrises and sunsets every day, yet across the year, the angle and duration of those lights subtly change. As Earth tilts, the station's orbit alternates between longer stretches of sunlight and longer intervals of shadow. These fluctuations affect temperature, energy generation, and even the circadian rhythms of the astronauts themselves. During certain months, the station remains bathed in nearly continuous light. During others, it spends much of its orbit in darkness. To help the crew adjust, engineers have programmed the interior lighting to mimic a stable day-night rhythm, anchoring human biology to something familiar amid the endless orbit. Though the International Space Station floats far above weather and clouds, it is not beyond the reach of seasons. It, too, is bound to the same cosmic tilt that governs the migration of birds, the sprouting of seeds, and the thawing of ice. In every sunrise it sees, in every eclipse by Earth's shadow, there is the whisper of the same universal rhythm that turns winter into spring. The passing of light and shadow around the planet is a reminder that even technology, the epitome of human control, still dances to the tune of the cosmos. Seasons shape more than light and temperature. They guide disease, agriculture, migration, and behavior. As temperatures rise in spring, bacteria and insects awaken, spreading pollens and spores across continents. In animals, hormones respond to changing daylight, triggering migrations, breeding, and dormancy. Crops germinate and ripen in time with the arc of the sun, and the pulse of human civilization itself has always followed this rhythm. Long before satellites could measure carbon dioxide or watch plankton bloom, ancient observers tracked the sun's path across the sky, building calendars and temples aligned with solstices and equinoxes. The tilt of the earth has always been humanity's quiet metronome, dictating harvests, rituals, and lifeways. Seen from space, these cycles merge into one vast choreography of light and color. Continents breathing green, oceans glowing with plankton blooms, polar caps waxing and waning, clouds shifting in planetary rhythms. Every living thing, from the smallest microbe to the orbiting machines above, participates in this eternal sequence of inhalation and exhalation, of energy absorbed and released. Earth's seasons are more than changes in weather. They are the heartbeat of a living planet, pulsing in harmony with the tilt of its axis and the journey around the sun. From methane frosts on distant exoplanets to forests turning gold in autumn, from Mars' dusty storms to the ISS drifting through sunlight, the rhythm is the same, a cosmic breath, the endless exchange between light and darkness, warmth and cold, life and rest. Across the vastness of the cosmos, every shifting hue, every drifting cloud, every whisper of wind or glint of ice is part of that shared, timeless rhythm, the quiet song of worlds turning toward and away from their stars, forever breathing in the light. The changing temperature of each season reshapes the behavior of nearly every species on Earth, including humans. Mosquitoes thrive in the warmth of summer, spreading diseases like malaria and dengue wherever the heat allows them to survive, while frost in winter halts their spread, forcing their populations into dormancy until the return of warmth. Crops, too, follow the same ancient rhythm, growing only within specific temperature ranges that dictate the timing of harvests, a cycle that has guided human civilization for over 10,000 years. Animal migrations are tuned to these same cues. Birds follow the rising warmth toward nesting grounds, mammals chase the greening of vegetation, and whales trace the path of plankton blooms across the seas. Even the movement of human diseases echoes these patterns, rising and falling as environmental conditions change. The Earth's seasonal heartbeat determines when food grows, when animals move, and when pathogens flourish. Today, scientists track these cycles with remarkable precision, using satellites, sensors, and data models to map how the tilt of our planet shapes the health of ecosystems and societies alike. From farm fields to forests, from bacteria to elephants, every living thing follows the steady rhythm of temperature and time. Yet that rhythm, once stable for millennia, is now shifting. Allergy seasons, for instance, are lengthening as global temperatures rise. Pollen counts now climb earlier in spring and persist longer into autumn. The warming climate extends the growing seasons for plants, particularly those that produce allergenic pollen such as ragweed, birch, and many grasses. Higher levels of carbon dioxide in the air further intensify the effect by boosting pollen production itself, increasing the burden for millions who suffer from seasonal allergies. In some regions, the allergy season now lasts several weeks longer than it did just 50 years ago. These changes ripple through ecosystems and human societies alike. Shifts in rainfall, frost, and blooming patterns alter when and where plants grow, changing landscapes that once seemed familiar. The drifting of seasons once signaled renewal and predictability. Now it also brings uncertainty. Even microscopic grains of pollen, carried invisibly through the air, have become messengers of a changing climate, whispering of transformation on scales far larger than any single plant or city. In urban environments, the very shape and texture of civilization rewrite the seasons. Heat stored in asphalt, brick, and glass blurs the boundaries between summer and winter, creating what scientists call the urban heat island effect. Pavement and concrete absorb sunlight during the day and release it slowly at night, raising city temperatures by several degrees compared to surrounding countryside. As a result, snow melts faster, frost arrives later, and trees bud earlier along city streets. Birds alter their migration schedules, and insects once killed by cold now survive the winter in growing numbers. Buildings, vehicles, and human activity add even more warmth, reinforcing the effect. In some megacities, summer now stretches far beyond its natural limits, erasing the crisp transitions that once divided the year. Global warming amplifies this phenomenon, turning urban areas into laboratories where scientists study how human infrastructure interacts with climate. The result is a world where the familiar rhythm of the seasons blurs, replaced by a new, human-made tempo of heat, light, and stone. Far from the city's snow itself, the emblem of winter is retreating northward at an astonishing pace of about 50 kilometers per decade. Satellite records spanning the past half-century reveal how snowfall zones have been migrating, reshaping entire ecosystems and economies. In regions that once saw thick blankets of snow, warmer temperatures now cause much of the winter precipitation to fall as rain instead, pushing consistent snow lines farther toward the poles and higher up mountain slopes. This steady retreat of snow alters water supplies, threatens ecosystems, and impacts industries dependent on winter conditions, from farming to skiing. Snowpack, which once acted as a natural reservoir by slowly melting to feed rivers in spring, now vanishes sooner, changing the timing and quantity of water flow downstream. In some areas, this shift leads to droughts and shorter growing seasons, while in others it increases the risk of flooding. The timing of snowmelt arrives weeks earlier than it did in previous generations, forcing plants, animals, and people to adapt to a hastened world. Each flake still forms through the same delicate dance of freezing vapor, but the geography of where those flakes fall is rewriting climate maps in real time. Once considered a symbol of purity and permanence, snow is now a moving frontier, retreating like a silent tide. The melting of ice from the planet's polar regions contributes steadily to rising sea levels, exposing ecosystems long entombed in frozen silence to erosion and awakening ancient microbes that have slept for millennia. Each summer's melt peels back layers of history, revealing fossils, trapped gases, and landscapes unseen for tens of thousands of years. The thaw is both revelation and warning, a quiet demonstration of how quickly even the most seemingly eternal parts of Earth can shift. Scientists can read the memory of this transformation by studying glaciers, where each year's freeze and thaw leaves a delicate signature behind. Within the heart of ancient ice lie alternating layers, one from the warmth of summer, another from the deep freeze of winter, each containing microscopic bubbles of air, grains of pollen, and specks of volcanic dust. These preserved traces form a frozen archive of the planet's atmosphere, holding within them stories of ancient climates, volcanic eruptions, and changes in greenhouse gas concentrations. By drilling into these icy vaults and counting the layers like pages in a diary, scientists can measure temperature and carbon dioxide levels stretching back hundreds of thousands of years. The oldest continuous ice core, taken from the heart of Antarctica, reveals patterns of warming and cooling that span over 800,000 years. Each delicate line in the ice marks another full revolution of Earth around the Sun, another turn of the seasons, another breath in the long rhythm of time. In this language of frozen light, time becomes visible, and the Earth's own memory is written not in ink or stone, but in the shimmering, translucent layers of snow turned to crystal over ages. Much like the glaciers, trees write their histories in rings. Each tree trunk, sliced through its core, reveals a series of concentric circles, light, wide bands from the generous warmth of spring and summer, and darker, narrower rings from the leaner months of autumn and winter. These annual rings not only tell a tree's age but whisper the story of its life, the droughts that slowed its growth, the seasons of heavy rain that allowed it to flourish, the frosts that bit at its bark, and the years of peace and sun that thickened its heartwood. Scientists can read these tree rings like sentences, translating the subtle differences in thickness and hue into records of rainfall, temperature, and even volcanic activity. When overlapping the rings of old and young trees from the same region, researchers can reconstruct the climate across thousands of years, long before humans ever kept written records. Each forest becomes a vast, living library of time, each tree a chronicle of sunlight and soil, water and wind. Even when a tree falls, its story does not end. The pattern of rings remains preserved, holding within it the rhythm of countless seasons, the pulse of the planet turning beneath the sky. Beneath the ocean's surface, coral reefs record their own history in skeletal form. Coral polyps, small creatures that build vast underwater cities of limestone, grow layer by layer, their skeletons recording the chemistry of the seawater in which they live. These layers form bands much like the rings of trees, alternating between lighter, less dense layers during warm seasons and darker, denser ones during cooler months. Scientists can take tiny cores from living corals without harming them, revealing the sequence of seasonal changes encoded within. The width and composition of these coral bands record fluctuations in sea temperature, salinity, and nutrient availability, offering a window into centuries of oceanic history. Through this natural archive, researchers have traced patterns of El Niño events, monsoon cycles, and long-term shifts in ocean circulation that shape global climate. Coral records complement ice cores and tree rings, filling in the missing stories from the tropics where glaciers do not form. Each coral reef thus becomes both a living ecosystem and a time capsule, preserving the moods of the ocean across generations. As warming seas threaten to bleach and dissolve these delicate organisms, their layered skeletons remain as silent witnesses to the ocean's changing past and uncertain future. Even in the stillness of caves, time leaves its mark. Stalagmites and stalactites, those shimmering mineral sculptures that hang from or rise from cave floors, grow imperceptibly as water drips from above, leaving behind minuscule deposits of calcite. Over thousands of years, these layers build up, forming visible bands that record the chemistry of the water from which they formed. Each layer corresponds to the world outside. Wet seasons lay down thick, clear bands. Dry seasons leave faint, thin traces or halt the growth altogether. When scientists analyze the isotopes in these layers, they uncover a record of rainfall, vegetation, and temperature changes stretching back 500,000 years in some places. Stalagmites in the caves of China, South America, and Europe tell of ancient monsoons, great droughts, and climatic oscillations that shape the rise and fall of civilizations. Like the ice cores and tree rings, these formations speak the same language, the universal rhythm of growth and rest guided by the Earth's rotation and orbit. Within the deep quiet of the caves, drop by patient drop, the story of the seasons continues to write itself, indifferent to the passage of human time. Every living thing on Earth, from coral polyps to human beings, owes its existence to this slow, ceaseless rhythm, the heartbeat of the seasons. It is the tilt of our planet's axis that breathes life into this rhythm, tilting us gently toward or away from the sun, shaping every gust of wind and every wave that laps the shore. Without that tilt, there would be no spring or autumn, no migration, no harvest, no bloom or decay. The alternation of light and darkness, warmth and cold, dictates the circulation of the oceans, the breathing of forests, and the migration of birds and beasts alike. Even the rise of civilizations traces back to humanity's ability to read and follow this rhythm. Our ancestors built calendars, temples, and rituals to honor it, planting and reaping by its pattern. Every cultural festival of renewal or rest, every tradition that marks a year's turning, echoes the same celestial dance that began long before humans walked the earth. But the rhythm runs deeper still. It lives within us. The same cycles that move the tides also shape our internal worlds. Hormones, moods, and sleep patterns shift subtly with the changing light. Our bodies remember what our calendars often forget. When days grow shorter, we slow down, seek warmth, and rest more. When light returns, our energy rises. The rhythm of the seasons, written into the tilt of the planet, is also written into the pulse of our blood. To live on Earth is to live in harmony with that rhythm, whether we are aware of it or not. Each breath we take aligns with this grand planetary pattern, the slow rotation that guides the tides, the sprouting of seeds, and the migration of stars across the night sky. High above, unseen, Earth continues its graceful motion. It tilts gently, tracing an invisible arc through space, an ancient dance that gives rise to every climate, every current, every sunrise. This movement is so smooth, so steady, that we rarely think of it, yet everything we know depends upon it. Because of that tilt, snow melts and rivers flow, flowers open and leaves fall, deserts bloom after rain and oceans inhale and exhale through their waves. Every creature that has ever lived, every fish, bird, and human, has measured its life against this same rhythm, this cosmic heartbeat that marks the passage of time not in hours, but in cycles. Tonight, as you close your eyes, imagine the planet gliding silently through its orbit, the sunlight shifting softly across the curved face of the world, dawn unfurling somewhere, night descending somewhere else. From this vast perspective, the year no longer feels like a collection of dates, but a great circular wave, slow and eternal. Somewhere, a glacier begins to melt, and somewhere else, new ice forms. The balance holds, always in motion, always returning. Around you, the rhythm continues. The air cools and warms, stars move gently overhead, and life adjusts to the subtle cues of light and shadow. The trees outside sense the lengthening night, and beneath the soil, tiny seeds are already preparing for spring's return. Even your own heartbeat, steady and calm, echoes the same pulse, slowing with the fading light, resting as the world tilts toward the quiet of winter. The seasons, in their endless procession, remind us that change is not something to fear but to trust. Every ending holds a beginning within it, every fall of snow the promise of melt, every dust the certainty of dawn. The earth has kept this rhythm faithfully for billions of years, circling its star in quiet devotion. As you breathe, you are part of that unbroken pattern, a single note in the vast, gentle symphony of time. So, let the world keep turning without you for a while. Let the pull of gravity and the hum of the orbit rock you into rest. Tomorrow, the sun will rise again, ever so slightly in a different place. Somewhere, light will lengthen, elsewhere, shadows will grow. But for now, you can surrender to stillness. The year will keep its rhythm, the earth will keep its course, and the slow, beautiful turning of the seasons will go on, carrying you softly with it into dreams, as it always has, and always will.